All right, gas law mini lesson. Um, so the only gas law I put on here is the ideal gas law because while it does give you the ideal gas law on here, it doesn't tell you what the parts are. And I wanted you to know the parts. The P is pressure, V is volume in liters, N is number of moles, R is the gas law constant, which if we're using atmospheres, which I'm going to try and use atmospheres for everything that you do with the ideal gas law. And temperature is in Kelvin. Remember, Kelvin must be in Kelvin, so Celsius plus 273. Um, and all these are pretty obvious. If I have two pressures and one volume, then I know I'm going to use this guy. And if I have two temperatures and one pressure, I know I'm going to use this guy. But it's basically just figuring out what I need to solve for. So here I have a volume, and I have a pressure, and I have a temp. And they're asking me how many moles. And so when they ask me how many moles, that's a dead giveaway that I'm going to be using ideal gas law because none of these other guys have number of moles in them. So there's no way to calculate number of moles, whereas ideal gas law has that little n, which is the number of moles. So I have a pressure in atmospheres, 2.8 atm. And I have a volume in liters, so I don't have to do any conversions there. And I have a temp already in Kelvin. Oh, that's very handy. And I have an R value, the gas law constant, which I'm using atmospheres, so I can use that gas law. You'll notice they give you for the one for using atmospheres, the ones for using kPa, and the one for using torr. Oh, did I write that down wrong? Oh, yeah, I printed that off wrong. Woo, look at that. Caught me. 821. Wow. Anyway, well, you caught me in one of my errors, so it's 821, so 0.0821. I guess I just mistyped it when I typed up this sheet. But anyway, hopefully I'll correct you. It'll be on the board. And I'm calculating n. So I want to get n by itself. So the first thing I'm going to do is I'm going to multiply 2.8 times 98 liters. And that's going to give me 274.4. And then I'm going to multiply 0.0821 times 292. And that's going to give me 23.9732. And then I'm going to divide. I'm going to take 274.4, this answer, and divide it by this answer, and that's going to get n by itself. So divided by 23.9732. So my number of moles, n equals 11.4461. And again, I just multiplied these guys together to give me this. And then I multiplied these guys together to give me this. And then I divided this by the 23.9732. And so that gives me n. N equals, and that's my final answer. So that's my final answer. So every question that you're looking at here, you're basically looking to see if it contains a moles. If it does not contain a moles, it's going to fit into this category here of gas law. So I have liters, which is a volume. I have a temperature, which is 20 degrees. So I have a volume and a temperature, and I have another temperature, which is 45. So I'm going to change those to Kelvin. And then I'm going to put 35 liters over whatever, let's see, 20, 273, 283, 293 Kelvin equals x liters over 273 plus 45, 273 plus 45, enter 318, and solve. And and you're going to solve for x liters. And that's how all of these work. all these problems, you're just seeing which one they fit into. That's how you should attack any problem on the final exam. You should go, okay, I have 2 temps and 1 volume. 2 temps and 1 volume. So this is going to be this guy. Okay? Thanks, guys.